Hello, hello. I hope everyone's doing well. I want to talk to you briefly about compound inequalities. So if you could get out your Unit 3 toolkits, we're going to get some definitions down. So first let's start with just what is a compound inequality. A compound inequality consists of two or more inequalities, and they're going to be joined by either the word and or. So, for example, you might have something like x plus 3 is greater than 7, or x is less than or equal to 12. So I essentially have one inequality, a second inequality, and they're joined by the word or. So that's an example of a compound inequality. So now that we know what a compound inequality is, let's talk about what the words and or mean. And so you know what the words and or mean, but specifically in math, when we say and, we mean intersection. We mean like this and this. So like both. If we have event A and event B, I want something that's in the intersection of A and B, this like shaded blue region. So in other words, if I were to say, I want like a hot dog and a hamburger to eat, I want both the hot dog and the hamburger, right? I'm not going to be happy with just one. Or in other words, it's what do they have in common? On the other hand, the word or means union. So normally when you think about like that hot dog and hamburger example, if I say I want a hot dog or a hamburger, I normally mean like one or the other. This would be like hot dog, this would be like hamburger. But in math, or is a little tricky because it really means one or the other or both. So if I say I want a hot dog or a hamburger, it's kind of like I would eat a hot dog, or I would eat just a hamburger, or I would eat a hot dog and a hamburger. Or in other words, like if it's in one item, it's a part of the solution. So those are our definitions. Today we're just going to focus on the or compound inequalities. So if you can make sure that you get the note sheet for today, we're going to go through the notes. So just a quick or example. Again, this is an example of a compound inequality because we have two inequalities and they're separated by the word or. So we're going to start by graphing compound inequalities. So you're going to graph just each inequality separately. So x is greater than 4. So gets an open circle at the 4, and x is greater than 4 would be all of those numbers shaded because those are all the solutions. So x is less than or equal to 2. Be at 2, I would color it in, and then I would shade down below because these are all the numbers that are less than or equal to 2. And then to combine these or to graph the compound inequality, I would combine the two graphs. So I would have like this part starting at the 2 and going below. And then, oops, I started at 3. Hold on. Oh, goodness. Okay. Sorry about that, guys. So 4 above, 2 or below. So when I combine the two graphs, this is what it would look like. So I'm just going to graph them on the same graph. And then I say, what's the union of the two graphs? So remember, or means one or the other or both. So think about all of the numbers or all of the solutions that are in one of the inequalities, the other inequality, or both. So for example, all these numbers over here, like 5, 6, 7, 8, 9, 10, those are solutions to this part of the inequality. So they should be a solution to the entire compound inequality. On the other hand, all these numbers down here are a solution to this compound or this part of the inequality. So they should be a part of the compound inequality solution as well. So really, whenever you have an or, it's kind of like this whole thing. That whole thing is a part of, or is the solution to the compound inequality. So really, the only numbers, think about it, the only numbers that are not greater than 4 or less than or equal to 2 are the numbers in this like kind of blank space here, like 3, 2.5, 3.9, you know? So any number in the middle there is not a solution. All right, let's try another one. So we have x is less than 1, negative 1, sorry. So we would start at negative 1, gets an open circle, and we would shade this way to the left, or x is greater than or equal to 3. Looks like that, right? So we graph each one individually, and then when we combine them, we think about what's the union? Where's the solutions that are one or the other or both? So you just kind of graph it and then leave it. That's my final answer. That's my final solution. And hopefully this should look familiar because you've probably done this before. So now going down to the practice problems. Before we were just graphing. Now you're going to actually have to solve and graph. So now you're going to have to actually solve the inequalities first and then graph the solutions. So number 1, to solve for x, we're going to divide both sides by 2. So x is less than negative 3. And then over here, we're going to solve this inequality separately. So these are like 2 separate inequalities. We're going to divide by negative 7. So x is greater than or equal to positive 3. And I need that word or in the middle. So there's my solution algebraically. And now that I have my solution, I'm going to graph it. So remember, we're just going to graph each one individually. So, oh gosh, I did that again at the 2. Sorry, the negative 2. So I'm going to have, ooh, I can't erase. It's not letting me erase right now. So pretend that's not there. But we would start, let me graph it down here. So negative 3 or below, and then positive 3 gets a closed circle or above. And then there's my solution. So there's going to be 2 parts to my solution, the algebraic solution and then the graph as well. So try number 2. In number 2, you can see that these are both inequalities are already solved for x. X is by itself. So I don't actually need to solve algebraically. I can just graph. So x is less than 2. Or x is greater than or equal to 4. There you go. And then one or the other or both would be everything that's shaded. So some more practice problems. Go through and try and solve these. If you want, you can always pause the video. And then when you resume the video, you can just check your answers, or you can follow along with me if you'd like to. So we're going to solve. We're going to get x by itself first by adding 3 to both sides. So x is greater than 11. And then the second part here, remember we're using SADMAP, right? Order of operations backwards to get x by itself. So we get rid of our subtractions or additions first. So we're going to get rid of that plus 1. So we have x over 2 less than or equal to 5, right? And then to get x by itself, we can now multiply because this means x divided by 2. So x less than or equal to 10. So here's my solution. X is greater than 11. This doesn't quite go up to 11, so we're going to make one more tick mark. So x is greater than 11, or x is less than or equal to 10. So fill that in, and there you go. So my solution algebraically and graphically. Number 4, again, we're going to use SADMAP. So we're going to get y by itself Getting rid of our subtractions or additions first, we need to get rid of that -3, that -3 there. So we're going to add 3 to both sides, and we have 5y greater than or equal to 15. And then divide both sides by 5, y greater than or equal to 3. But now we need to solve this other inequality. Add 3, 2y is less than 2. And then get the y by itself by dividing. Y is less than 1. So algebraically, I fill in that word or, and then there's my solution. So now I know that y is greater than or equal to 3. Or y is less than 1. And there's my solution, my graph. All right. So now here's some extension problems. Now I want you to write a compound inequality. So remember, that's like 2 inequalities with the word or in the middle for each solution set shown below. So if number 5, if this is your solution, think about where your shaded regions are. They start here at this -2 and go down that way, right? So we can say that x or a or b or y, whatever is variable you want to use, is less than, because we're shaded to the left, right? So it's less than -2, but then I also noticed that the -2 was filled in, so it's actually less than or equal to. And then if I look over here on the right side, this 1 has an open circle, and then we're shading like above that. So we're going to say that x is greater than 1. And of course, I need, remember, the word or in the middle. So there you go. There's my compound inequality. So we're kind of like going backwards. Now I'm giving you the graph, and I want you to write the inequality. And then in number 6, think about what this says in words. All real numbers that are less than -1. So that's going to be 1 inequality. So let me use y now. I could use any variable. Is less than -1 or greater than or equal to 4. So or the number has to be greater than or equal to 4. There you go. And so those are compound inequalities, but specifically with the word or in the middle. We are going to talk about compound inequalities with the word and in the middle next time. So I'm just going to show you a couple examples, and I want you to maybe try these on like the bottom of your paper, and you'll see the solutions too. So try this, try and solve this, and pause the video now while you're solving it, and then when you unpause, I'll show you the solution. All right, so there's the solution. So down here in red is your answer algebraically, and then your graph should look like that. All right, let's try a couple more. So pause the video, solve this, and graph. All right, so now when you unpause, let's check your answer. This should be your solution algebraically, and then your graph there in red. All right, here's another one. So again, pause the video. You can work on this. Okay, so now here's the solution down here. And then your graph there in red. And then I think we have 2 more. So again, copy the problem down, pause the video, try this problem, solve it, algebraically and then graph. And then now when you unpause, check your answer. This is your answer algebraically. That's what you should get. And then the matching graph. And then last one. So again, copy this problem down and then pause the video and solve it and then graph it. All right, now that you've paused and unpaused, here's your solution and then the matching graph. All right. So that is it for compound inequalities with ORs. Don't forget that you have the compound inequalities homework worksheet, and that's going to be due next class. Thanks so much for watching. I hope you have a great day.